Hello and welcome to the C programming lecture on binary and hexadecimal. What is binary? Binary is just a numerical system that has a base of 2. So in other words, it can only represent one of two states. Below we'll see a series of bits, and each of these bits can be in either one of two states, either on or off. Now using a collection of bits, we can actually represent larger data structures or numerical values. In this particular case, this is how we represent the number 20 inside of a integer value. So you may have the third bit position, maybe the 4 value, and perhaps within here the 1, 2, 3, 4, 5th bit position is possibly the 16 value, which is represented in decimal. So that is how we achieve this 20. So what is hexadecimal? Well, hexadecimal is also a numerical system. However, this is a base of system that is 16. So this means that 16 different values are represented by a single placeholder. And how we represent those values is the digits 0 through 9, and then the letters A through F. So you've probably seen some of this stuff in, if you've ever worked with computers or colors or any of those things, there's typically like hexadecimal displays for certain things. So a single hexadecimal value can represent 4 bits worth of data. So again, here is a chart of, and below, this is a hexadecimal representation, the lower portion, and then the upper portion is the decimal representation. So we can see it's 0 through 15, 16 pieces, and then 0 through 9, and then A through F. So here are some examples of different decimal, binary, and hexadecimal values. So 16 can be represented, obviously what we're used to is using the number 16 in decimal. This is the binary representation of 16. And here's the hexadecimal representation. So you can see that we can actually compact binary in a nice fashion by using hexadecimal. And once again, here's the value 15. 15 represented in binary. We can see that we have the ability to in particular one digit or one placeholder inside the hexadecimal is able to represent 4 bits inside of binary. So this is why all of these bits are turned into 1, because this particular value is F. Okay, so here is 128. We can see that this is how 128 is represented. And we can see that that would be an 8 and hexadecimal, 0x. Typically, you will see this notation 0x for just to let you know the following values are hexadecimal. And here's an interesting one, 255. All the bits are turned on, and then actually both of the both of the positions that represent an entire byte are turned to FF. Okay, so a brief review. Binary and hexadecimal are just two different numbering systems. Using hexadecimal actually allows us to represent large binary values in a more compact way. And it's often the default way of representing binary data. So just try to play with some of this stuff and get a little bit more comfortable with it. I would suggest like just looking at some larger numbers and figuring out how you can translate that to hexadecimal, typically integer values. So that way you can reason about how you convert from one to the other, and then maybe even go into a level deeper and see how you can take that hexadecimal and then turn that into the actual bits. Thanks for joining me on this lecture, and I hope to see you in the future.